For today's lecture, we will do first we will run through the quiz we did on Tuesday. And then I will do a full review on the lecture. So like what you need to do the discussion worksheet, and then we will work on discussion worksheet problems. And then if we still have time, we will be working on the discussion. Like there are like 2 or 3 problems that we didn't finish last time. Yeah, and the attendance will be taken during the process of working on the discussion problem, like sometime in between. Yeah, so I guess I will just start with walking through the quiz solution. So for true and false, so that's quiz 9. True and false, problem 1. Problem 1 is true. It is possible to determine the equation of PDF given the equation of CDF, because you can just like take derivative of CDF to give the PDF. Because CDF is defined to be the integration of PDF, so you can just do the other way around to get PDF. You are given a CDF, so that's true. The second problem, suppose that fx, so the answer of that is false. The question is that suppose fx is equal to x, and x is defined from negative 0.5 to positive 0.70 otherwise. So then f is a valid PDF. This is false because since we're given that fx is equal to x, and x can be a negative number, so fx itself can be, let's say if x is negative 0.5, fx is negative 0.5, but fx itself is a probability. It can be negative. So that's false. And written problem. Written problem 1. The question is that fx is cx squared, where c is a constant and x is in a range of negative 2 to 0. So if f is a valid PDF, we need to find the value of c. So remember, like how do we check if f is a valid PDF? We're required to take integral from negative infinity to infinity, fx dx, and we want this to be 1. So again, like x is in the range of negative 2 to 0. So essentially, we just need to take the integral from negative 2 to 0, because all the other range are like the function itself is 0, so we don't care. So fx is cx squared dx. And the integration of that is cx cubed over 3, taking the range from negative 2 to 0, and it's equal to 8 over 3 times c. And we want this to be 1 because the sum of all the probabilities together has to be 1 for a valid PDF. So we know that c is 3 over 8. The answer for problem 21. And for problem 2, we want to find CDF of f from above. So CDF is defined to be fx equal to I didn't say why is it negative 3 over 8. I didn't say why is it. Okay, so for second problem, CDF fx is defined to be negative infinity to x, fx ft dt. Okay, I will just let the conversation in the discussion chat go, where I will go through a solution for problem 2. So CDF is defined to be fx integration from negative infinity to x ft dt. In this case, we don't care about like the values from negative infinity to -2, because they are 0. X is only defined from x is only non-zero in -2 to 0. So this integral is same as -2 to x ft dt. And what is f here? F is cx squared. But now we calculate c already. So f is a over 3 x squared. So if we like integrate the result, that will be t cubed over 8, choosing from -2 to x. And the answer is 1 plus x cubed over 8. But like, in order for CDF to be valid, you need both the solution of the CDF and the range of CDF. So fx is equal to 0 when x is less than -2, because like x is 0, like, and if x is below -2, we haven't like encountered any like positive probability yet. And when x reaches -2 to 0, that's where like that's what we are just calculating. And after like you sum from -2 to 0, the probability, the cumulative probability has already reached 1. So like so after that, the probability has already 1, and x is when x is greater or equal to 0, that's like the probability of that is 0, because it's defined to be 0 at that place. So yeah, so this is a complete answer for problem 2. And then for problem 3, now to find the mean and median for PDF. So the mean is defined to be from negative infinity to positive infinity x as x dx. And fx is 3x squared over 8. And we only care about the range from -2 to 0. So the integral is x times 3x squared over 8 dx, which is -2 to 0, 3x cubed over 8, which is 3x to the 4th over 32 from -2 to 0. And the answer of that is -3 over 2. So that's mean. And to find the median, it's the same thing as solving the equation that from negative infinity to m of fx dx is equal to half, because half of the probability lies on the left of the median and half of them on the lies on the right. So that's the same thing as -2 to m 3x squared over 8 dx equal to half, and want to find what m is. And after you calculating the results, that will be like solving an equation of 1 plus x cubed over 8 equal to half, and x is equal to negative the cube root of 4. Yeah, so that's the solution for problem 3. And for problem 4, we have like a similar problem before. So let me just read out the problem log. Suppose that each student has 10% chance of going to office hours, and this is the probability, and this probably is independent whether other students go. So like each student is independent with each other. So problem A, choose a random student let X be the random variable that outputs 1 if it goes to office hours and 0 otherwise. What is the expectation and standard error? So X is a random variable that only outputs 1 or 0, whether a student goes to office hour as a success or not. So we know that this is the Bernoulli trial. And with a success of P equal to 0.1, that means the student goes to office hours. But we know that the expectation of a Bernoulli trial random variable is just a probability, which is 0.1. And the standard error of any variable is the square root of the variance of this variable. And we know that the variance of a Bernoulli variable is PQ, where Q is defined to be 1 minus P, it's the failure rate. So this is the square root of 0.1 times 0.9, which is 0.3. Part B, what is the probability that in a section of 25 students, at most 4% of them go to office hour? So like, don't intimidate by percentage. So 4% here is just the same thing of 1 over 25. Yeah, and then why do I use a fraction instead of percentage to make sure that you are not intimidated? Because because essentially we have 25 students, and each student is a Bernoulli trial. That means 25 students itself, the event itself, is a binomial distribution. 25 Bernoulli trial is a binomial distribution. And binomial distribution is a discrete random variable. It's not continuous random variable. So we don't use usually if we use percentage, we're dealing with continuous random variable. So right now, we're talking about discrete random variable. So a fraction is a better visualization of a discrete random variable. And we know that it's a binomial trail. And when we want to calculate the probability that at most one student goes to the office hour, that means we want to calculate the probability of X equal to 0 plus the probability of X equal to 1. And for binomial distribution, X equal to 0 is 25 to 0 times the success rate to the 0th power times the failure rate to the 25th power plus 25 plus 1, 0.1 to the first power, 0.9 to the 24th power. And that's the result for part B. And for part C, we want to use CLT to approximate the probability that at most 4% of the section of 25 students go to office hour. So we let X bar be the average of the Xi for the student. And this is the percentage, the average percentage of students who go to the office hour in the section of 25 students. So what is mu bar? Mu bar is just mu because each student are identically distributed. So the average of them are the same of each student, which is 0.1. Sigma bar is sigma divided by the square root of n based on CLT, which is 0.3 divided by square root of 25, which is 0.06. So essentially, we want to calculate the probability of X bar less than 0.04. So we can use CRT to finding the z-scores. So the z-score is defined to be X bar minus mu bar divided by sigma bar. So so essentially we're calculating the probability of z bar less than 0.04 minus mu divided by sigma bar, which is 0.1 less than 0.06. So this is the probability of B bar less than -1, I think. Yes. And then you can like check tables to get the result of that. Yeah, and the result is like 0.1387. Okay, so that's all for the quick solution. Okay, there are some students asking me that they can't really log into this thing here. Just telling them just log in to the normal discussion in Zoom. It works. Okay. Yeah. So let's go. So let's go to. Let's do some like review on the lecture material before we work on problems on discussion. So in this discussion, we're pretty much talking about variance and mode for continuous random variable. So the variance of continuous variable is defined to be the integral from negative infinity to infinity x minus mu square fx dx. So that's the definition. But like we don't use too much of the definition. Instead, we use a lot about the variation, which we also proved in class that sigma square is equal to the integral from negative infinity to infinity x squared fx dx minus mu square. Yeah, like there's a proof for that. So basically, you just like expand the parentheses out. Yeah, I'm not gonna go detail, but like expand the parentheses out, you will get like a minus 2 mu square and plus mu square, and you will get only minus 1 mu square. But like don't intimidate it by this equation here, because this is essentially saying that the variance is equal to the expectation of x squared minus the expectation of x, the whole thing squared. Like the variance is these two are the same thing. It's just like when we are dealing with continuous random variable, we use integration to calculate this, and we use integration to calculate this. And when we're dealing with discrete random variable, we use summation to deal with the expectations. So that's the only difference. But like definitely be familiar with this equation. We're gonna use it a lot in this discussion. And actually, like you may feel pretty boring after like you have practiced a lot, and that's the exactly point. Like once you feel a little bit boring, like you know what to do, that means like you are fully understand the process of this, how to solve the problem. So another thing is mode. The mode is of a random variable is defined to be the highest frequency of certain value. So mode is usually like if you are given a PDF that's like in a range of AB, that's there exists a C in the range of AB such that FC is the maximum. So when FC is maximum, we know that C is the highest frequency of appearance. So C is the mode. and we will go like in detail for like more concrete problems. So maybe like go to your discussion worksheet 19 and then start working on problem 1. And then like if you finish problem 1 or like if you have like try your best on problem 1, please like update with me so I know like when should I go through a solution. So you can like start working on problem 1 now. Yeah, and definitely let me know if you like finish problem 1, or I'll just like wait. You're supposed to just complete one, but like if you finish, instead of like waiting, you can just work on other problems. I need to make sure like there's like clearly amount of people who do the problem, and a lot of people are like asking me questions like simultaneously, so I'm answering like some small problems like each person has right now. So like as long as I find that, so this is kind of like me going through each of you to answer one-to-one problems, but like remotely. So as long as I feel like there's like the time is good for us to go through together, I will go through the problem. But like if you finish problem one, definitely work on the rest of the problem. And also I think it's a good time to go through problem one right now. So problem one says that let x be a Pareto random variable with parameters that a equals to 4, and also find the variance of x. So according to lecture, we define Pareto random variable as fx equal to a minus 1 over x to the 8th power. And we define the range of x is from 1 to infinity. So x is greater than 1. So in this context, we're given that a equals to 4. So fx is 4 minus 1 over x to the 4th, which is 3 over x to the 4th. And we want to calculate the variance. To calculate the variance, we need to calculate mu first. Because remember, variance is defined to be negative infinity to positive infinity x squared fx dx minus mu squared. This is just e of x squared. This is just e of x squared. So we need to find the mu first. The mu is defined from negative infinity to positive infinity, x times fx dx. But since our range for random variable is x greater than 1, we only care about 1 to positive infinity, x times 3 over x to the 4th. That's our like function. And this is equal to integral from 1 to infinity 3 over x cubed dx, which is negative 3 over 2 times x to the negative 2, ranging from 1 to positive infinity, which is 0 minus negative 3 over 2, which is 3 over 2. So that's mu. And we have solved that, and we want to like solve the first part. So we want to calculate the positive and negative infinity of x over fx dx. And again, the range is just from 1 to positive infinity, because that's where like x is defined to be non-zero. And then we just calculate the integral x squared times 3 over x to the 4th dx. And this is 1 to infinity 3 over x squared dx, which is negative 3 over x from 1 to infinity, which is 0 minus 3, which is 3. So variance is just 3 minus 3 over 2 squared, which is 3 over 4. So that's the answer for variance. Yeah, any question on problem one? Like feel free to ask on the chat.
How I thought we were supposed to subtract mu squared.
Yeah, I'm subtracting here.
Oh.
You see it?
Yeah.
Okay. Okay. Any other questions? If there's no question, you can work on problem 2 and problem 3. And like, please update with me with your progress, because I need to like move on and go through. Like even if you didn't finish, like you have a question, you can ask me. And if you like don't know how to do that, you can just like tell me through the chat. So at least I know like what people are doing. Yeah. Okay, I received a lot of questions, but I haven't received too many people saying they are done. Like if you are done, please send me a private message. If you're not done, that means like most of the student in the class is not done. So I just wait. I mean, if you don't reply me with question or you are done, that means you are in the progress of solving the problem. So I'm supposed to wait. Okay. So let me walk through the answer for problem 2, and after that, I will take an attendance. So problem 2 says a random variable with PDF given by fx equal to e times e to the x, and x is defined in the range of x is less than -1, and there's 0 otherwise. So we want to find mu first to calculate, because in order to find the standard deviation, we need to find the variance. It's just the square root of the variance. So in order to find the variance, we need to find the mu first. So mu is defined from negative infinity to positive infinity as fx dx. But we only care about the part when it is negative infinity to -1, because that's where x, the range of x is non-zero. So that's just x times e times x e to the x dx. And we need to do like a lot of calculations here. So we first take the constant out. So that's e times -1, negative infinity, x ex dx. And then we do an integration by parts. So we let u to be x, v equal to ex dx. So du is dx, or this dv. So v is ex. According to integration by parts, this integral is x times ex from negative infinity to -1 minus integral of v du. So it's ex dx. So that's just e times x ex from negative infinity to -1 minus ex from -1 from negative infinity to -1, which is e times negative e -1 minus 0 minus e to the -1 minus 0. So answer is -2. And then we want to calculate the variance. To calculate the variance, we need to find the integration from negative infinity to positive infinity x squared fx dx minus mu squared. So we need to handle this integration. So you can do that by integration by parts. So like let's first write out the integration out. So that's from negative infinity to -1 because we only care about this range. X squared times the function, which is e times e to the x dx. Like we will minus this at the very end to avoid confusion. So that's equal to e times negative infinity to -1 x squared ex dx. So we do an integration by parts, so that u equal to x squared, dv equal to ex dx. So du is 2x dx, and v is ex. So the function equal to uv, which is x squared times ex minus c du. I mean, for solving this integral, you can do another integration by parts. But remember, at the beginning, we have already calculated this integration. So this integration, we have already calculated the result. This is equal to -2 over e, because after we times e, that it goes to -2. So this is just like 2 times the integration we had there. So it's just like 2 times negative 2 times like 2 over e. So that's just this integration. Being minus by this value here, which is e to -1 minus 0, the total thing times e. And at last you will get the result is 1. So the standard deviation is just the square root of variance, but the variance is 1, so standard deviation is also 1. Okay. Before we move on to problem 3, maybe let me do a quick attendance check. How do I do that? Polling. Lunch poll. So you guys should be able to see the poll right now.
I can't see any poll. Wait, we can't see any poll.
You can't see the poll?
Mm-mm.
Oops. I don't know. Maybe I should end the poll and relaunch the poll. Can I see it now?
Yeah, we see it.
Is that a yes or no? Or no?
Yeah, we see it.
Oh, great. Yeah, you will have 2 minutes on doing the poll. You have 1 more minute to do that. There's still like 6 of you haven't voted yet. Like you have to vote in 1 minute, or I will close the poll, so you will not be considered as attending the section. Okay, the poll will be closed in 20 seconds. Okay, I will close the poll in 3 seconds or 5 seconds. That's your last chance to do the poll. There's still like some students haven't do the poll yet. I will close the poll. Okay, so the first question: do the integration on PDF to find the CDF? This is true because that's exactly the definition. CDF is defined to be the cumulative function of PDF. So you just do like integration of PDF to find CDF. Second question: both discrete random variable and continuous random variable has a valid CDF. That is correct. So remember, if we have like continuous random variable, the cumulative distribution is something like that. And then the last it will reach 1. But if you have a discrete random variable, the distribution will be like the function itself will be also pretty discrete. And at last you will reach 1 somewhere. But still, this is a valid CDF. It's just a discrete version. So yeah, if you like did wrong in this problem and don't know how to solve this problem, you should like review the basic concepts because these two questions are pretty basic. Okay, so I guess I will give you like, or never mind. I will go through problem 3. So problem 3. The question is, we're giving a PDF of fx equal to 2x over 3, and x is in the range of 1 to 2, and we want to find the variance and mode. So again, to find the variance, we find mu first. Mu is from 1 to 2. That's the range of x non-zero. X times 2x, x times fx dx. So I'm just writing it directly instead of writing multiple steps. So that's just calculating the integration of 2x squared over 3 dx. And the result is 14 over 9. And then we want to find the integration from 1 to 2 x squared fx dx, which is 2x over 3 dx, which is calculating the integration from 1 to 2 to x cubed over 3 dx. And last you will find the result is 5 over 2. And I want to find the variance, which is precisely 1 to 2 x squared 2x over 3 dx minus mu squared, which is 5 over 2 minus 14 over 9 squared, which is 13 over 162. So that's the variance. And then we want to find the mode of this distribution. The mode is defined to be, mode of a random variable x is defined to be the highest frequency of appearance in the range. So for this problem, we're given that PDF is 2x over 3 in the range of 1 to 2. And we know that the PDF is maximized when x equal to 2. Fx is maximized. So 2 is the mode of random variable of this distribution. Okay, is there any questions? If not, please work on problem 4 and problem 5. Problem 4 is like very similar to what we did before. Problem 5 is need a little bit more work. Okay, let me go through problem 4. I'll leave you more time on problem 5. So problem 4 says a PDF is given by fx equal to -4 over x to the 6. Then x defined in the range of x less than -1. I want to find the standard deviation. So we need to find mu first. Mu is from -infinity to -1. X fx dx. And then this is equal to -infinity to -1, -4 over x to the 4th, which is 4 over 3 x to the -3, -1, -infinity, which is -4 over 3. And the variance is -infinity to -1, x squared times -x5 times 4 dx minus mu squared. So this integral is just integration from 1 to -infinity to -1, -4 over x cubed dx, which is 2 over x squared from -infinity to -1. And this is just 2. So the answer is 2 minus -4 over 3 squared, which is 2 over 9. So the standard deviation is the square root of variance, which is the square root of 2 over 9, which is square root of 2 over 3. Okay, that's like the same logic as before. Problem 5 is a little bit different. I will give you like 5 minutes to do that, and then I will go through a solution. seems that I forgot to mention how do you find mode for problem 4. So for mode in problem 4, fx, the PDF is -4 over x to the 5th, and the range of x is less than 1. And usually there are two ways to find the maximum. Like for finding the mode, you are always finding the maximum of PDF in the range. So you can just like first look at the function, and then I mean obviously if the function has a mode, it has to be -1 because the other thing are not like, I mean yeah, but like you can draw the graph out. That'll be like the graph will be something like this. But given that x is less than -1, it maximized at -1. Another way is to like do derivative. So if you do the derivative, you will find that this is actually a monotone function. It's actually a monotone, and then you will find the result. Like for other functions that is not monotone function, you can do a derivative or something and then set up at 0. That means like when derivative is 0, that means the function has to keep something and then drop down, like because this point is derivative of 0. That means it is either a local maximum or a local minimum. Then you can just like go through all the things that make derivative 0 to find the actual maximum. Yeah. So that's like here, that's something you should be already know in your first calculus class. Yeah, and I will give you 2 more minutes on problem 5. Okay, let me go through the solution for problem 5. Actually, like a lot of JSI are currently asking why they are having the problem on logging in the Zoom account. And then like I just tell them that they have to go to the berkeley.zoom.us site. I don't know, that might be like school changing the policy of contracting with Zoom. Okay, but aside of that, let's work on problem 5. So for problem 5, we're given that x is a uniform random variable, continuous random variable in 0 to 10. So after knowing that, we can find the PDF directly. PDF is just 1 over 10. And the way we get 1 over 10 is because for uniform distribution, the PDF is 1 over b minus a. It's 1 over 10 minus 0, which is 1 over 10. And then we want to find mu. Mu is from, in this case, range non-zero ranging from 0 to 10, x, fx. And fx in this time is a constant. It's just 1 over 10. And then you will get the result. Which is 5. And then you want to find the variance, which is 0 to 10 x squared times fx dx minus mu squared. This is equal to 0 to 10 x squared over 10 dx minus 5 squared, which is equal to x cubed over 30 from 0 to 10 minus 25, which is 3 over 100 minus 25, which is equal to 25 over 3. So we know that the standard deviation is just the square root of the variance, which is the square root of 25 over 3, which is 5 times square root of 3 over 3. So that's exactly the same thing that as we did before, but later on we need to find the probability of mu minus sigma up to mu plus sigma.
Wait, Zeha? Why is
Oh.
it not, x cubed is not 100? Or 10 cubed is not 100, I mean.
10 cubed is 1,000 and the denominator is 30, so
Oh,
it will be 100 over 3.
okay, thank you.
Okay, so then we want to find the probability. And one thing I want to highlight here is that if you want to find the probability of that, we always need to check. We have to mark it in right. We also want to check if, so say like x is from A to B. We want to check if, like which is smaller, mu minus sigma or A, and then check which is bigger, mu plus sigma or B. Because when you are doing like integration, like so finding probability is calculated integration in this range, but you can't just do like if we are given that the distribution is like this, and the range of non-zero is just from A to B, you can't just do like when like mu minus sigma is something like less than A, and mu plus sigma is something bigger than B. You can't get like if you take the integral in this range, you are like over calculating the stuff here. Instead, you are just doing like which one is smaller. You can just do like integration from A to B. But for this problem, luckily, mu minus sigma is just 5 minus 5 times square root of 3 over 3. It's greater than 0. And 5 plus sigma is less than 10. So we just need to do the integration on these two numbers. So P of mu minus sigma to mu plus sigma is just equal to the probability of x greater than 5 minus 5 square root of 3 over 3, less than 5 plus square root of 3 over 3, which is the integration from 5 plus sigma to 5 minus sigma fx dx. Fx is a constant in this case. And last you will get the result. It is square root of 3 over 3. Okay, so that's the end for our problem 5. Let me quickly go through the true and false. So the answer of true and false is true, false, false, true, false, true, true, true. The first problem, for discrete random variable with finite range, the standard deviation always exists. That is correct because the standard deviation is calculated by a summation for discrete random variable, and it is always a finite number. But for problem 2, a continuous random variable standard deviation does not always exist because you are essentially calculating an integral, and the integral sometimes can go to infinity, and that's when the standard deviation does not exist for continuous random variable. And for problem 3, it is possible for variance to be negative. That is false because variance is the square of standard deviation. It's always non-negative. Problem 4, for continuous variable, if the mean does not exist, then the standard deviation doesn't exist. That is correct because remember, mean is just expectation. It's the integral. It's the integral of x fx dx. Well, for standard deviation, we need the integral of x squared fx dx minus mu squared. We need this. So if the mean doesn't exist, that means this already goes to infinity. That means the standard deviation will definitely go to infinity. So it doesn't, both of them doesn't exist. For problem 5, if the mean exists, then the standard deviation exists. That is wrong because it exists a situation that the mean is a finite number, but the standard deviation is infinity. So that's wrong. For problem 6, that is correct because that's essentially the definition or like the variance, like the first variation of the definition of the variance. And for problem 7, actually I'm not sure about like the answer whether it's true or false. For problem 7, you should like double check later, and if you have the answer, you can please tell me, because for exponential, the answer is true, but I think it's false because for exponential random variable, the mean is 1 over c, and the standard deviation is also 1 over c. So the probability of mu minus 1.5 standard deviation, mu plus 1.5 standard deviation is like 1 over c minus 1.5 1 over c to 1 over c plus 1.5 1 over c. Like, isn't it like pretty dependent on c? Like, I think that should be false. But I don't know. Should like double check. And yeah. And for problem 8, that is correct. That's exactly the same thing Professor went through during the lecture. The definition of parallel random variable. You can like check it back. So I will stay here for another 1 or 2 minutes for answer your more questions, and you're like dismissed. Feel free to leave.
Zihao, could I ask a question?
Okay.
So like in this worksheet, they started using like standard deviation. So like, do we
Yeah.
talk? Is like standard deviation thing what standard error is?
Oh, I have replied to you a lot of words.
Yeah, I
So-
saw the difference, but is like the way you calculate them the same then? Or-
Well, like I think we are pretty much dealing with standard deviation right now. Because standard error is when like we're doing like the sample mean, and then we're doing like a central limit theorem that we want to like estimate the true population mean. But for now, like we are all dealing with standard deviation. So standard error only happens when during the central limit theorem.
Okay, thanks.
Because right now we are given a distribution, and then we want to find the property of this given distribution. That means we are dealing with standard deviation. Any other questions before I end the meeting? Okay. So I will assume that there isn't any questions, and I will end the meeting. If you have further questions, please don't hesitate in contacting with me.